So we've set channel 1 to be level measurement, channel 2 pressure measurement, channel 3 temperature measurement. We give it a name. We then decide what type of input it is. This is a hardware input, and the source is wired to C1, which is the first current input on the back of the device. In configure source, you can see it's set to read a 4 to 20 milliamp, just high and low limits above the threshold so that we don't get an outer range error. On processing, so this is where we tell it what that 4 to 20 milliamp signal represents. We're assuming a linear signal from 4 to 20 milliamps. Now we can go in and change the scale. So here we put in the output units for the device, the measurement units, and we tell it what we want 0.1 and 0.2 to represent. In this case, 4 milliamps is 0 meters, and 0.2 is 20 milliamps is 80 meters, which is the calibrated range of the submersible level sensor. Now we want to decide how we want to display that value. So we're saying it's 1 decimal point. You've got options there to change. And how do you want it to be represented on the graph on the visual display? So just 0 and 80. If you're only ever going to work it within, say, 20 meters, then you'd make that 20, so you get much more better resolution at your actual measurement. Same for the pressure. We just went in and said it was in input C2 this time, and the processing was 20 milliamps is 10 bar. So it's a 0 to 10 bar, 4 to 20 milliamp device. And that is essentially how you set up the channels. In channel 4, in logical channels, you can either drop down to see your channels listed here, or you can just jump between each one with the up and down arrows. So if we go and make channel 4, let me just check. Channel 4 was going to be the pH electrode. So pH measurement. It's a hardware input. We're going to wire it to C4 on the current input. It's a 4 to 20 milliamp device. Just set the limits outside of the 4 and 20. And we want it to be a linear measurement with the engineering units being pH, and this was 0 to 14 pH. So we're at 4 milliamps, 0 pH, and at 20 milliamps, 14 pH. Don't need any filtering or rounding. We want it to be 1 decimal place, and the maximum scale to display would be 14 pH. And that's it. We've added a new device. Just add the conductivity measurement here. So this is calibrated 0 to 50 millisieverts. So the 4 to 20 milliamps, so it's 4 is 0 millisiemens, and 20 milliamps was 50. level, pressure, temperature, pH, conductivity. So now we've got those channels listed, the instruments connected. We need to decide how it's going to be displayed, because at the moment it will be 6 channels per group. You've got 10 groups that you can bring in any logical channel to. So we might want one group for pressure, one for temperature, one for pH, etc. Or you want all 5 displayed in one group. So at the moment it's in all in a single group, but obviously we've got 5 sensors and it's showing a 6th channel, which is unnecessary. There are 10 groups, so you can create any combination of logical channels in any group. So if we go ahead and change the groups, so group 1 here is enabled. We'll give it a name, sensors. This is how you configure it visually, and this is where you bring in the channels. So 1, 2, 3, 4, 5. You can change the color and theme as well if you want to change how it appears. And in here we want to disable it so it doesn't show up at all. Down here we can set up the data login options. So if we say we always want it data login, this group of 5 sensors, and then we can set it to data log every, let's just say 5 seconds. So now we can see the 5 sensors, level, pressure, and you can maneuver these around if you just change it in the group settings if you want to see it visually different. Here you can see the green LED is flashing or changing every now and then. This is the data logging indicator, so if we click on it you can pause data logging from this menu. From a visual perspective, the different modes of viewing the channels. This is the numerical view. Then we change the mode to the bar graph view, where these will increase and decrease based on the input to the channel. This is the scrolling graph, so you can see trends. Analog looking gauges, for those who like to see the old mechanical gauge settings. And this is a diagnosis page where you can see up to 5 groups presented in one instance. Once these sensors are connected, these will obviously give the current reading, scaled reading in each of the independent inputs.